Hi scholars, so before we start I just want to remind you to grab a paper and pencil or a whiteboard and marker, just something you can write on in order to solve with me today. So the first thing we're going to do before we even start the lesson is just this quick do now, so review how to represent equations using arrays. So go ahead, pause the video now, solve this problem, and while you pause, you can take advantage and grab any materials you need if you don't have them with you at the moment. So again, pause the video now, grab your materials and solve these two equations or represent them using arrays. Then press play when you're ready. All right, if you're watching now, that means you have grabbed your materials and you have solved these or represented these two equations using an array. Okay, so let's start with 9 times 4 equals 6. You should have drawn 9 rows of 4, as you can see here, and along the side I have written or skip counted by 4s to get my answer. So when I skip count by 4s 9 times, I get 36 as my answer. So let's look at 6 times 7. What would that look like in an array? So I have 6 rows of 7. Notice that the first factor is always the number of groups or rows, and the second factor is always how much are in the group or the size of the group. So if I skip count by 7 6 times, I get 42 as my answer. So let's move on to our learning intention. Thoughtful mathematicians model the commutative property of multiplication using tape diagrams. So I want you to pause the video now, read this vocabulary to yourself, and then press play when you're ready. Again, pause, read the vocabulary to refresh your memory, and press play. So you may or may not remember that the commutative property of multiplication simply means that switching the order of the factors does not change my answer. So that's why here 6 times 4 equals 4 times 6. 6 times 4 is the same thing as 4 times 6. Doesn't matter if I write the 6 first or the 4 first, I'm going to get the same product. And I'm going to draw a tape diagram to prove that. Well, 2 tape diagrams. So let me draw my first one. So I don't know the product right now, but for 6 times 4, that would mean that I have 6 groups of 4. So let me go ahead and make 6 groups. And in each group, I'm going to draw 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So skip counting by 4s. My answer is 24. So I want to draw another tape diagram to represent the related fact of 4 times 6. So that is 4 groups of 6. So I have my 4 groups now, and I want 6 in each group. So now I can skip count, but I already know the answer is 24 because the commutative property tells me that the answer does not change. But let's skip count to be sure. 6, 12, 18, 24. So we are correct. So let's try one together. We're going to solve this problem using a tape diagram. 7 clowns hold 3 balloons each at the fair. Draw and label a tape diagram to show the total number of balloons the clowns hold. So let's go ahead and draw our tape diagram. So whatever I'm doing on the screen, I want you to do with me. So go ahead and draw your tape diagram. We don't know the total, so we're going to put a little question mark there. What we do know is that there are 7 clowns and each of them has 3 balloons. So 7 clowns holding 3 balloons. Is our group the 7 clowns? Do we have 7 groups? Or is the group the balloons? Do we have 3 groups? So we actually have 7 groups because there are 7 clowns. Oops. There we go. Sorry, we want to do it more kind of closer to in the middle. I'm going to do 3 on this side and 4 on the other side. So it doesn't have to be perfect, but you want to try and make it as even as possible. So I have 7 groups in my tape diagram. So go ahead and make sure you have 7 groups in your tape diagram as well. And now what should we do with these balloons? So we're going to fill in the 3 balloons for each clown. So let's skip count as we do this. So 3 so far here. And then we added 3 more here, that's 6. So we keep going 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So the clowns hold 21 balloons. All right, let's look at the problem you're going to do on your own. George swims 7 laps in the pool each day. How many laps does George swim after 3 days? So you're going ahead and draw your tape diagram and use that to solve this equation, or this word problem, sorry. So please pause the video now. Press play when you've already solved and already checked your work. Again, pause now. Solve this problem using a tape diagram, and then press play to check your work. All right, so let's go ahead and start with our tape diagram. And in this problem, there were actually 3 groups because he's doing the laps every day, and we're trying to figure out how much that would be after 3 days. So that's 3 groups. And each day, he does 7 laps. I'm going to fill in 7 in each. I can skip count by 7 to see how much that is. 7, 14, 21. So our total is 21. George swims 21 laps. All right, thanks so much for watching. That's the end of our mini lesson. So go back to Schoology and follow the next steps. Thanks, everyone.